Okay, welcome to your last video for the acid-base solution unit. Next unit after this we're going to start is going to be stoichiometry. So last thing to cover is basically our indicators. So we've talked about pH, we've looked at calculations. So there's basically three ways that we can measure pH. We have a pH meter, which is something that we use in the lab, and obviously you didn't get to use that this year. But hopefully next year in Chem 30, we will all be back at school and you will get to use the actual pH meter. It's kind of a little like probe, it's like a long stick kind of thing. You stick it in your solution, you swirl it around, and then it's going to tell you what the pH of your solution is. It's just going to give you a little readout on a screen. Then we have pH paper, so those are the little strips that you're going to use, little tweezers. You're going to dip it into the solution, you're going to see what color it is by matching it up to a little chart, and that will tell you what the pH number is. Then we have indicators. So indicators are chemicals which are going to change color depending on the pH of the solution. So if you go close to the back of your red data booklet, you will see that there is an indicator table. Okay, this table basically has all the different indicators that we use, and it tells you what color they are at different pH values, right? So that table basically looks like this. It's on page 10 of your data booklet, okay? So columns that we are basically interested in at this stage of the game, the name, right? So this column here tells us what indicator we have. So like methyl violet, cresol red, thymol blue. We're interested in the pH range. So you'll notice that different indicators have a different range. And then we're interested in color change as pH increases. Okay, the other two columns of this table you'll use when you're in Chem 30, but we don't use them here. So if we look at our first one in here, right, the methyl violet, you can see that it gives you a pH range of 0 to 1.6. So this pH range and this color change go together. So between 0 and 1.6, my color is going to change from yellow to blue. So what that means is if I add methyl violet and I see that the color is yellow, okay, so if I see yellow with methyl violet, that is telling me that my pH has to be something less than 0, right? Because to get yellow, I have to be down here. Okay, if I get blue, that means my pH must be greater than 1.6. Okay, the reason for that is between 0 and 1.6, I am changing from yellow to blue. So the color between yellow and blue would be green. So if I saw that my color was green, that would be telling me that my pH is somewhere between 0 and 1.6, okay? So what you find with indicators is I don't get a specific number, right? So for example, if I use methyl violet and I see that as blue, all I know is that the pH is something greater than 1.6, right? It could be 2, 3, 4, 5, could be 12, could be 14. I have no clue, right? So we definitely choose either different indicators if we kind of have an idea of what the pH is we're looking for, or sometimes what we do is we test one solution with like 3 or 4 different indicators so that we can kind of narrow down a little bit and then check with the next indicator, narrow it down a little bit more, and so on. Okay, so normally one of the labs we would do, we'd be generating something that kind of looks like this. Okay, so we take like a sheet of paper, we basically laminate it, and then obviously before we laminate it, we print all of this stuff on it. And then you can kind of see here how we've drawn like these little circles onto the sheet of paper. So then what we're doing is we're taking our solutions and we're dropping them onto the sheet, right? So all down this column, we have put solution number 1, which has a pH of 1. All down this column, we've put all of solution 2, which has a pH of 3. Right, and then keep going like that. And then here we've put some unknowns, so an unknown X, Y, and Z. And so then what we've done is we've taken our alizarin yellow R and we've put that all the way across, right? And so now what it does is it kind of creates this table where I can compare to, right? So for example, if I look at X, Y, and Z over here, so if I'm looking at these 3 unknowns over here, I can probably start to get a little bit of an idea of what kind of pH they have just from how they look, right? So for example, if you look at Z over here, right, it's kind of clear with this clump in the middle. Well, look here, this pH 1 was also clear with a clump in the middle. So from that, I can probably narrow down that Z probably has a pH pretty close to 1, right? Same deal with X. I can be like, okay, well, color-wise, it looks kind of similar to 12, right? It might be a little more extreme, but at least I can kind of match that up. But when I look at Y is that bigger unknown area, right? Color-wise, this could be 9, it could be 7, it could be 5, it could be 3. I don't really know. And so that's where then we start going to other indicators, right? And so then we look at the next kind of one, right? And so now here's thymol blue. We kind of have this pink, kind of have this bunch of yellow ones. I'm not super sure why these two look a little darker. They're probably more or less the same. And then we have this blue, right? And again, oh look, X is also blue. It's looking pretty close to that pH 12 solution, right? And if we continue to scroll down it, we do really see that it looks quite similar, right? It's maybe a hint lighter when we get here. So maybe it's not actually 12, maybe it's 10 or 11 and kind of somewhere in between here. But you can see how we can use some of these known colors, right? Which is basically what you have in your data table, right? It's telling you here what these colors are. So by knowing what color is what, I can start to narrow down what some potential pHs are, right? So if we think of Y, from the first indicator, I'm saying it's anywhere between 3 and 9. That's not really super helpful, right? Y, I go to thymol blue, I'm still kind of in that like, ooh, could be this, could be that, not super sure, right? Then I look at bromothymol blue. Color-wise, oh, these are some weird colors for bromothymol blue. It could be the 9, it could be the 5. Not sure why these two look like this. Those definitely should still be yellow, so I'm going to go with it's probably more of the 9. Then we look at these colors, right? It's colorless, so again, I know it's not 12, but I kind of already knew that, right? And then you can kind of keep trying to match some of those different ones up. So lab-wise, we would normally do something like this. Question-wise, though, this is kind of more the type of question that you'll generally see, right? So this type of question here, we'd basically be like, we took one unknown and we tested it with all these different indicators, and these are the colors that we got. So you'll generally find that we don't want to add all the indicators into the same test tube, because if I just have one sample and I'm adding everything to it, I'm going to get a hodgepodge of colors and I'm not really going to know what color is what indicator. So normally what we do is we take our unknown and we divide it up into a bunch of different little containers, kind of like that sheet of paper had, right? We split them all up so that then we can really see, okay, this indicator was this color, okay? So how is this going to work? We're going to look at our test tube. So test tube number 1 is methyl orange and it was yellow. So we're going to go to our data booklet. We're going to find methyl orange, okay? So here's the methyl orange. And it said what? It was yellow, I want to say. Yeah, it was yellow. So methyl orange being yellow. If I look here, yellow is over here. So that must mean it's greater than 4.4. Okay, so from here, this is telling me that this is greater than 4.4. So we've narrowed down the range somewhat, right? We're not anymore between 0 and 14. We're now something greater than 4.4. So next indicator is bromothymol blue, and that one is blue. So we go back here, we find bromothymol blue, which is here, and it's blue. So blue's over on this extreme. So that means it's greater than 7.6. So again, we've now narrowed it down a little bit more. The first indicator said it was greater than 4.4. Now we're saying it's greater than 7.6. So this one now is kind of out of the game. We don't care about it anymore because we now have a smaller range, right? We're now between 7.6 and 14. So now we have thymolphthalein. So thymolphthalein says it's light blue. So we find our thymolphthalein, which is here. So it's light blue. So you'll notice this goes from colorless to blue. So light blue probably means it's in between those two colors. So now we're saying between 9.4 and 10.6. So again, we've narrowed that range down a little bit more, right? Before we were just saying it was greater than 7.6. Now we're able to say, no, it's somewhere between 9.4 and 10.6. So hopefully these last two indicators are going to help us narrow it down even more. So now we have that alizarin yellow R is orange. So alizarin yellow R being orange, well, orange is the color between yellow and red. So that tells me it's somewhere between 10.1 and 12. So these together now narrow it down more, right? I know it can't be 12 because this one told me it couldn't be more than 10.6. So between these two, I can narrow it down to being between 10.1 and 10.6. We can check to see if the last one narrows it down anymore. So indigo carmine is blue. So indigo carmine being blue just means it's less than 11.4. So we've already narrowed it down to 10.1 to 10.6. So that doesn't narrow it down anymore for us. So we're able to conclude that the pH of this solution is somewhere between 10.1 and 10.6, okay? So this is kind of how you use indicators, not like a super accurate thing. It's not like I can add an indicator and get an actual number, but I can definitely try to narrow down a pH by using a variety of indicators, okay? So yeah, that is basically your acid-base solution unit.